Hi guys, welcome. This is week 8, so we're going to be going over lesson 100, and that's going to be the end of the units. Then we'll be reviewing in class. So really the video is only going to cover lesson 100, which is estimating square roots and irrational numbers. So again, we know our perfect squares, or if we don't, we can go back and review those: 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6, 7, 8, 9, 10, 11, 12. Usually we take it out to 12 as far as memorizing the multiplication tables. So square root of 25 is 5. Square root of 36 is 6. But then if we're looking at the square root of 29, well, that's irrational. It's not a perfect square, so it's going to give us an irrational number. Well, I know the square root of 25 is 5. Square root of 36 is 6. The square root of 29 is between these two numbers. So it's going to be, the answer would be between 5 and 6. So again, estimating maybe 5.4, 5.5. Again, we can go into, even though this is not really what we're getting at when we do this, in irrational numbers. So we go in here and we do square root of 29, and it gives us that big long decimal, so closer to 5.4. But again, it's an estimation, so we don't have to be perfect. We just know that's not a perfect square. And we know the square root of 25 is 5, and the square root of 36 is 6. So the square root of 29 has to be somewhere between 5 and 6. It's an irrational number that continues on forever, so we don't need to be exact. But if we were plotting it, it would be somewhere along there. Okay. Between which two consecutive whole numbers is the square root of 200? Okay. Well, if we said 20, 10 squared is 100, so maybe 20 squared is 200. Well, 20 squared is 400, so that's way too large. 15 squared is 225, so we're getting a little bit closer. 14 squared is 196, so it's going to be somewhere between 14 and 15. And again, if we looked at it and we did, well, square root of 200 is 14.14213, continuing on forever. So it's a little above 14 and less than 15. But we can know the integers that it's between based on what we know about perfect squares. And again, back to the square root of 29 example, well, 5.4 squared, 29.16, so a little bit over 5.3, 28.09. So again, there's no number we can put in because it's irrational, meaning we would have to do an infinite decimal and then square it to get it to be 29. So we can get really, 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 really close, but we're not going to be able to get it. Irrational numbers, again, we can use them. We call them root. They are real numbers. So rational and irrational numbers are both real numbers. We'll get into imaginary numbers when you guys get into high school. When you take the square root of a negative number, you can't do that because no number squared equals a negative number. So that's where we introduce negative numbers in order to, I guess, make sense of those square roots of negative numbers. So if we look at these numbers, pi, irrational, square root of 2, irrational, 2.3 repeating forever, that's rational. That can be written as 2 1/3, and negative 1/2. Okay. Rational as well, because it can be written as a fraction. So if we plot those on the number line, square root of 2 is going to be between 1 and 2, because 1 squared is 1, 2 squared is 4. Yeah, between 1 and 2, 1 squared is 1, and then 2 squared is 4, and it's going to be closer to here. 2 1/3 or 2.3 repeating, 3.14 continuing on, and then negative 1/2. So they're real, so we can plot them along a number line, even though they may be irrational, like the square root of 2 or pi. Okay, irrational number just means that it can't be expressed as a fraction, and it has a non-terminating, non-repeating decimal. So like 0.3 repeating forever. Okay, even though it continues on forever, it's repeating. So it's rational because we can rewrite this as a fraction. We can write it as 1/3. And pi, we take that out, it's never going to be, it's going to continue on forever. It's never going to repeat or terminate, so therefore it's irrational. That's the same thing with any non-perfect square that we take the square root of. Anything that's not a perfect square that we take the square root of, it's going to be an irrational number. So a lot of times we point to pi as being irrational and kind of the one we always use as an example, but it's only one of really infinite irrational numbers. All right, and then we'll go over that practice set together, and then we'll get reviewing for the next test and get that test and keep moving on.